This video I'm going to go into more detail on a linear. We looked already at recognizing a linear. I'm going to stay with the example that I had for you. If you look there, you know, 18 minus the 11, 7. 25 minus 18, 7. What's the difference between 32 and 25? 7. And so we have a constant or a common difference here of 7. And then that allows me, oh, I just know to get the next bit, go up by 7, go up by another 7, go up by another 7, etc. So there is, I can just do this by the long way. I mentioned it at the very end of the last video. There is like a key to the pattern. So if you fill this in, and it tells you exactly how to fill it in your log tables. A is your first term, and D is your common difference, and you clean that up, and you end up with Tn is equal to 4 plus 7n. That's like the key to this whole pattern. If you want T100, 4 plus 7 times 100, and that will get you 704, which is the 100 part of your pattern. How would you prove that this whole sequence is linear? So there's a big difference between show it's linear. I've just shown it's linear. I can see there for myself that it's linear. And prove. Now, if you have already, looked at patterns, then you might just want to let the video play out if this is just revision. But if you haven't looked, just pause the video and see if you can figure out, like, what do I even mean? Like, how could you go about proving this? What does proof require? Like, can I just say, oh, yeah, I'll get the next part of the sequence today. Oh, sure, look at it. It looks linear. It looks like there's a common difference of 7 all the way along. Sure, the whole sequence must be linear. But to say, oh, it looks linear, or oh, I'm going to just assume the rest of it is linear, is not proving. So take a minute, have a look. What is it that you know about a linear sequence? And how can you use that information to prove that the full sequence that goes on forever is linear? So I'm going to talk now about how to prove it. So what I need to do here is, what do I know? T2 minus T1 gives me 7. T3 minus T2, so T3 is 25 minus T2 is 18, also gives me 7. Is there any general way of describing what's happening here? T4 minus T3 also gives me 7. To prove means I'm going to have like, no matter the value of this minus no matter the value of this, I should get 7. Is there any way to generally say any term minus the one before it gives me, in this situation, should give me 7? Because that's what seems to be the pattern here. And just because it's the pattern doesn't mean it's going to continue, but I need to prove that it's going to continue. So instead of saying T2 or T3 or T4, I'm going to bring in some algebra. I'm going to say Tn, no matter what the value of this is, if I subtract, now look what's happening. I subtract the one before it. Well, if this is the one I'm looking at, in terms of n, what is the one before it? So if that's the one I'm looking at and I want to subtract the one before it, then I should get 7 in this situation. This is what I'm expecting. If this doesn't work, then it's not proving that the whole sequence is linear. So I have Tn. How do I get Tn minus 1? Well, anywhere I have an n, I'm going to throw in an n minus 1. So Tn, I already have 4 plus 7n. And I need to subtract Tn minus 1. So into this, anywhere I have an n, I'm going to throw in an n minus 1. I'm going to work all this out. So that's 4 plus 7n minus, I'll leave it there, and I'm just going to work this part out first. Plus 7n minus 7, which gives me 4 plus 7n minus, that gives me a minus 3 plus 7n. That minus is going to impact everything after it. I end up at 7. So it doesn't matter if it was T5 minus T4, T20 minus T19, T100 minus T99. I'm going to get the answer 7 because I did it in terms of n, I did it in terms of algebra. That's proving that the whole sequence is linear. What else can they ask me to do with this sequence? So I have 11, 18, 25, 32, 39, 46. So I know common difference of 7. I know this is linear. I've proven that it's linear. What else can they ask? Well, they can ask you to turn this sequence into a series. Now, why would they ask that? Like, is there any real life example here of why this happens? So I always go for a money example usually. So if I decided, right, I'm going to start saving €11 this week, and I'm going to continue. Sorry, I'm going to start by saving €11 this week, and then next week I'm going to try and up that by 7. So I'll try and save 18 next week, and then I'm going to try and up that by 25 the following week, and I'll up it by 32 the following week. Well, how much will I have by the end of 6 weeks? 2, 3, 4, 5, 6 weeks. Okay, so I'd have 11 plus 18 plus 25 plus 32 plus 39 plus 46. And you can just throw that into your calculator and find out how much you'd have all together if you saved 11 the first week, 18 the second week, 25 the third, 32, then 39, then 46. That's just summing up your sequence. This is called just a series. So this is your sequence. And if you just sum up your sequence, we call it a series. And this does happen, like especially with money. Maybe not with this particular pattern, but it happens a lot with money. So is there any other way, like if I asked you to sum up the first 6, I would probably just throw that into the calculator. But if I asked you to sum up the first 100, well now, I don't want to have to do that. Not bit by bit anyway. So if we go here, there's the summing up. So if you want to sum up to the first 6, it'd be S6. If you want to sum up to the first 100, it'd be S100. And it tells you exactly what to fill in here for A and D as well. So I'm just going to go for S6. And that's equal to n over 2. So I'm saying n is 6, so 6 over 2. 2 times A. A is my first term. Plus n minus 1. Well, n I've said is 6, minus 1 is 5. Times my common difference, which is 7. So that gives me 3. 22 plus 35. And I end up with 57 times 3. 171. And just check that out. If you add 11, 18, 25, 32, 39 and 46, do you get 171? This is, the faster way to do it. If there's only 6 terms, this probably is slower. But if there's 100 terms and I want you to sum it all up, well then this is going to be the faster method. So that's mostly to do with linear. The only other question I can kind of foresee them asking is if they said 3x plus 2 is the first term of a sequence, 20 is the second term, and 2x plus 3 is the third, and they've told me that this sequence is linear. So again, I would pause the video if this is your first time looking at patterns. Otherwise, feel free to just continue listening to me explain it. But if you need to pause it and have a go yourself. Most of these questions are very doable if you have a go with them yourself. Okay, so I'm going to explain this now. What do you know about linear? Well, linear is in my log tables. Linear has a constant difference. If I want Tn, I could fill in that. If I want Sn, I can fill in that. And that's kind of it. Like T2 minus T1 should give me my common difference because it is linear. And it's not asking is it linear, it's saying it is linear. So when I get term 2 and I subtract term 1, I should get a common difference. I should get the same answer as if I subtract term 3 minus term 2. So what is term 2? 20 minus term 1, 3x plus 2. I should get the exact same answer because it is linear if I subtract T3 minus T2. So that's 20 minus 3x minus 2 is equal to 2x plus 3 minus 20. And you can bring all your x's to one side, so that goes over, becomes 5x. And then I have 20, that's 40, 38, 3, 35. X is 7. Of x is 7, then my first term is 3 7s, 21, plus 2 is 23. The next one is 20. The next one is 2 times 7, so that's 14, plus 3, which is 17. And there's the first 3 terms of my sequence now that I figured out what x is.